Hello, hello, hello. So this lesson is for 1-07, and we're working on the same situation that we were working with in 1-06. So quick recap. Claire is going to the grocery store to purchase some bulk salted almonds and dried figs. And the figs are $6 a pound, the almonds are $6 a pound, and the figs are $9 a pound. And we know that she spent $75 before tax. So we modeled this using the equation 6a plus 9f equals 75, where a represents the pounds of salted almonds and f represents the pounds of dried figs. So in 1.06, we found out that if Claire buys 2 pounds of almonds, she can buy 7 pounds of figs. And if she buys 1 pound of figs, she could buy 11 pounds of almonds. So last week most people were just solving this using guess and check. So figuring out how much money she spent on almonds and then guessing and checking how much money she had left to spend on figs. Today we are going to try to work on a new strategy. So I'm going to skip past number 1 and look down at numbers 2 and 3 because we want to see what happens when our answer is a decimal. So scrolling back up, our equation is 6a plus 9f equals 75. But if she bought 8 pounds of figs, how many pounds of almonds could she buy? So 8 pounds of figs at $9 a pound is going to give us $72. $72 spent on figs. So we want to figure out how much money she's going to have left. So if we do 75 minus 72, we end up with $3 left to spend on almonds. So in this example, I think we still could use guess and check because we know that the almonds are $6 a pound and that 3 is going to be half of 6. So I think we could use guess and check here to find out that it's going to be 0.5 pounds. Because if we do 6 times 0.5, it'll get us to 3. But if we scroll down and look at number 3, if she buys 6 pounds of almonds, how many pounds of figs could she buy? So we have 6 pounds of almonds at $6 a pound. That's going to be $36 spent on almonds. So then we want to figure out how much money she's going to have left over. We can do 75 minus 36, which is going to give us 39. And I can tell right away from looking at this that 39, there's no way that 9 is going to neatly go into that. So what we're going to do is we're going to take this 39, and the way that we can see how many times 9 goes into 39 is by using division. So we're going to divide this $39 by $9. You can plug that into your calculator and you'll get that it will be 4.3. So that's going to be not our A value, that's going to be our F value and the number of figs that you can buy. So 4.3 would have been pretty hard to come by via guess and check. I'm just going to go through the first one of these on the guided practice because I want you guys to take some time and think about this on your own before moving on to the exit ticket. But this time we are working with this equation here, and we don't have any context. We're not given a situation. This is a little bit more abstract. So for the first one, it just says substitute the value y equals 6 into this equation and solve for the variable x. So I'm just going to rewrite the equation, but instead of y, I'm going to write 6. And we have to put the 6 in parentheses because when we have this 5 next to this y here, they're being multiplied. So we need to multiply the 5 by the 6 that we're plugging in. So the first thing we're going to do is simplify because we have some multiplication here with two numbers that we know. So we can just do 5 times 6, which is going to give us 30, and bring everything else down. So we have 2x plus 30 equals 60. And then when we say using balanced moves, we're talking about inverse operations. So the first thing we want to get rid of is this 30, and the operation that's happening between the x and the 30 is addition. So we got to do the opposite of addition, and we're going to subtract, because subtraction is what undoes addition. So that'll cancel out. We can bring down the 2x equals 60 minus 30. It's just going to be 30. And then our last step, we need to use inverse operations again. So we're looking at 2x on the left side. Again, the operation that's happening between the 2 and the x is multiplication. So to undo that multiplication, we're going to do some division. So if we divide by 2 on this side, we have to divide by 2 on this side too. All that's left on the left side is x. And on the right side, we divide 30 by 2 to get 15. So for the rest of the examples on this page, you just need to plug in values and then solve using balanced moves. So thinking about the operation that's happening between the variable and the numbers, and then using the inverse or the opposite of that to isolate the variable.